Boys and girls, this is Mr. Manise here again with another amazing video, and in this video I'm going to walk you through how to solve each problem on the Unit 5 test review. My disclaimer as always is I need you guys to work these problems on your own, see what you know, and then and only then come to the video and iron out any misunderstandings, fill in the gaps, or figure out where your mistakes might have been. So without further ado, let's go ahead and jump in here. Unit 5 is on right triangles with exception of the law of sines and cosines, so there's a lot of information. It can be a little bit tricky. One of the reasons why this unit is tricky is because we got so many different ways to find pieces of information on a triangle. Okay, we got Pythagorean theorem to find a side. We got special right triangles that can also help us find sides. We got trigonometry that can help us find sines and angles, and we got law of sines and cosines that can help us find all the legs and angles. So it's really important that you guys understand which of those methods and strategies do you need to use to figure out the unknown pieces of information on these triangles. Okay, so let's go ahead and take a look at problem number 1 here. Okay, so we got information. I got a right triangle. I have a side, and an unknown side. Okay, so this is like SSS, right? I don't have any information about the angles other than the fact that this is a right triangle, 90-degree angle. Okay, so when I have two sides of a triangle and I'm trying to find the third, that's Pythagorean theorem all day long. So this is simply a squared plus b squared equals c squared. Okay, and again, it doesn't matter which one you label as your a and your b. I'll let this be the a, I'll let this be the b, and I'll let my hypotenuse be the c. So it's going to look like this. I got a squared, so I have x squared plus b squared, which is 4 squared, equals c squared, which is 6 squared. Now, when I taught you guys this lesson, I said there's only two things you do with Pythagorean theorem. Either you square both numbers, add them together, and take the square root, or you square both numbers, you subtract the two numbers, and then take the square root. If you're trying to find the hypotenuse, that's when you just square the two numbers, add them together, take the square root. But this time we're finding one of the legs, so we're going to have to subtract. So this is x squared plus 16 equals 36, and then this is why I say you subtract, because you're going to end up subtracting something from both sides. So I get x squared is equal to 36 minus 16, which is 20, and then you take the square root. Okay, well, let's see if we can break down the square root of 20. Okay, if you can't remember how to do that, you can use the trick that I taught you where you go to your graphing calculator, type in y equals the number divided by x, press second table, and you're looking in that chart of numbers for the largest perfect square that's in either column. Okay, so in this case, the largest perfect square is 4, so that breaks down into perfect land, square root of 4. And the garbage, the non-perfect land, I can't do anything with the square root of 5. Square root of 4 simplifies to 2. And so my simplified radical is 2 square root of 5. Okay, so that's Pythagorean theorem when I'm trying to find an unknown side. Number 2, I have 10, I have x minus 2. So I'm still trying to find an unknown side, but this time I don't have two sides. I only have one side. But I have information on all of the sides. Again, I don't have any information about these other non-right angles. Okay, so this is still Pythagorean theorem. So I'll let that be my a, let that be my b, and that's my c. So I have a squared, so I have x squared plus b squared. Now I got to square this whole binomial. I'm squaring the whole expression. Okay, and that equals a hypotenuse squared, 10 squared. Okay, so here, just bring this down. Now here, when you do x minus 2 squared, now if you want to come out here and do x minus 2 times another x minus 2 and first and outside and inside and last, you can do all that. Or if we remember our shortcut, you just square the first term, x squared. You multiply the first and second together, negative 2 times x is negative 2x. Double that, that's minus 4x. And then you square the back term. Negative 2 squared is 4. And that equals 10 squared, which is 100. Okay, let's go ahead and simplify. I can combine my like terms there. 1x squared plus 1x squared is 2x squared. Minus the 4x, I can go ahead and subtract 100 from both sides just to save one step. 4 minus 100 is negative 96 equals 0. Okay, so I got 2x squared minus 4x minus 96. Oh man, I got to do the rainbow thing. I got to do 2 times negative 96, and that's going to give me 192, and I got to do all that stuff, right? Enter the bell. No, no, no. We do not need to do the rainbow. Why not? The first thing that I always look for when I solve a quadratic equation is, number one, can I use the GCF method when there's no C term, or can I at least pull out a GCF? All three of these numbers are even, right? So I can factor out a 2. So I can pull out a GCF. Let's factor out this 2. If I divide all three terms by 2, that's going to leave me x squared minus 2x. Negative 96 divided by 2, that's going to leave me with negative 48. That's going to be equal to 0. All right. And remember, when you pull out the GCF, it just goes away, because if I divide both sides by the GCF, okay, the 2's cancel, 0 divided by anything is just 0, and I'm left with this quadratic equation, x squared minus 2x minus 48 equals 0. Okay, now I have a 1 in front. We just made our life a whole heck of a lot easier because we factored out that GCF. So here I'm going to look to see, can I factor when a is 1? I can't do the GCF, I can't do the square root because it's got a b term, it's not a special case. So when I factor when a is 1, I simply look at the c term. Are there any factors of negative 48 to add to negative 2? The first two numbers that pop in my head for 48 are 6 and 8. I don't know about you guys. Can 6 and 8 get me to a 2? Yeah, they're 2 apart. Okay, so this is going to factor. Now, one of them's positive and one of them's negative. The sign of the middle term will tell you the sign of the bigger one. So the bigger one, 8, has to be negative. So this is going to factor as x minus 8, and then the 6 will be positive. X plus 6. Both of these coefficients are 1, so I can flippy flip. X is equal to 8 and negative 6. Now, if I take a negative 6 and plug it back in, if I plug it back in here, I can't have a negative 6 length, so the negative 6 doesn't work. So our answer in this case is x equals 8. All right, so let's keep going here. Flip on over to the back. We're going to classify some triangles as acute, right, or obtuse. So remember, if c squared is bigger, okay, so here's my right. No, I can't do it. I need something smaller. No. Okay, here's my right triangle. If c squared is bigger, then that hypotenuse has got to open up, right? My angle's getting bigger, the hypotenuse is getting longer. So if c squared is greater than a squared plus b squared, then that's an obtuse triangle. All right, so we need to do a squared plus b squared equals c squared. So I need to do 0.3 squared plus 0.4 squared. Now, how do I know which one is c? It's going to be the biggest one, right? The biggest number. And then I'll need to compare that to 0.6 squared. Okay, so if we type all that in on a calculator, we're going to get 0.25. When I square these and add them together, I get 0.25 is less than 0.36. Okay, so this is the c, and this is the a plus b. This is c squared, and this is a squared plus b squared. When c squared is bigger, okay, I just did that little demonstration, then that's got to open up to form an obtuse angle. So this is going to be an obtuse triangle. When c squared is bigger, think large, obtuse, big. C squared is longer, bigger. Okay. Second one here, I'm going to do the same thing. The square root of 3 squared plus 2 squared, and I'm going to compare that to 3 squared. The square root of 3 squared is just 3. So we have 3 plus 2 squared is 4. 3 plus 4. And I'm going to compare that to 3 squared, which is 9. 3 plus 4 is 7. So once again, c squared is bigger than a squared plus b squared. So once again, we have another obtuse triangle. If a squared plus b squared equals c squared, then that would be a right triangle. Okay, let's do the last one here. Square root of 11 squared is just itself, plus the square root of 7 squared, which is just itself, and we're going to compare that to 4 squared. 11 squared is 11, 7 squared is just 7, and then compare that to 4 squared, which is 16. 11 plus 7 is 18. 18 is greater than 16. Okay, so the c squared in this case is smaller than a squared plus b squared, so that is going to give us an acute triangle. All right, number 4, solve for x. Again, I don't have any information about the angles. I've got side, 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 side. Okay, so when I'm trying to find a side, and I have information about all the other sides, that's still going to be Pythagorean theorem. But in this case, I have 2 different triangles, so I'm going to have to do Pythagorean theorem twice. In this one, I can use Pythagorean theorem to find this altitude of the triangle. So I'm going to put a variable there. I'll call that y. So I can do a squared plus b squared equals c squared. Okay, so I'll start with the y. Y squared plus 4 squared is equal to c squared, which is 4 root 5. I got to square that whole thing. Okay, so let's simplify. Y squared plus 16 equals, now I found that you guys made some mistakes on this on the quiz, so let me just refresh your memory how we do this. This is the way I would do it. I would just type in 4 second root 5, get a number, and then go ahead and press the square button where my finger is. Just press the square button. I'm going to do second answer squared, and that's what I get. I get 80. Okay, now if you want to do all that in one thing, you're going to have to use parentheses 4 second square root of 5, press over, get outside the radical, close the parentheses, and then press squared, and you'll get the same answer. Okay, I just found for me, when it's a couple of complicated steps, I just kind of do it on the calculator really quickly in like 2 or 3 short little steps. That way I avoid having to use lots of parentheses and that kind of stuff. Okay, so let's go ahead and get y by itself. So I'm going to subtract 16 from both sides. Y squared equals 80 minus 16, which is 64. I'm going to take the square root. That's nice. We get a nice round whole number. Y equals 8. Okay, so this guy is 8. All right, so now I have a side, and I'm trying to find another side. So that's still Pythagorean theorem. Now this time I'm trying to find my hypotenuse. So I just square the two numbers, add them together, and take the square root. So I'm going to do 8 squared plus 16 squared equals my hypotenuse squared, c squared. All right, so 8 squared is 64. 16 squared is 256. That equals x squared. Add those together, and I get 320 equals x squared. Take the square root. And first thing I would do on a big number like that is see, can you take the square root of 320? Let's type that in. Square root of 320. Nope, unfortunately that's a decimal. So if I want to see if the square root of 320 breaks down, let's use our little trick. Let's go y equals, and let's type in 320 divided by x. Let's go second table. And I want to see if there are any perfect squares. Okay, there's a 4 and an 80. 4 is a perfect square. There's a 5 and a 64. 64 is a perfect square. And I don't think we can get any higher than that. Okay, so this is going to break down into the perfect land, which is 64, and the non-perfect land, which is 5. Square root of 64 is 8. So this simplifies to 8 square root of 5, leaving it in simplest radical terms. Okay. Of course, we can go back and check our answer. I can do 8 squared plus 16 squared and make sure that equals 8 root 5 squared. So you can always go back and check your work on these things. Okay, so let's keep going. Number 5 through number 10. These are our special right triangles. How do I know that? Well, I see 45, 45, 30, 60, 60, 30, 60. So that tells me, okay, I'm on to the next topic that we covered in this unit, special right triangles. Okay, the first one, I have a right triangle. These are all right triangles. I have a 45-degree angle, so that means the other angle is also 45 degrees. So that means this is an isosceles. This is our classic 45, 45, 90 right triangle. And our, not really formula, but our relationship says that this is a side, and the hypotenuse across from the 90-degree angle is the side times the square root of 2. Okay, so if this is the square root of 2, then x has to be the same length because it's an isosceles triangle. So x is also the square root of 2. Now to find y, I take the side and I multiply the side times root 2. So y is going to be the side, which we already said is root 2, times another root 2. And root 2 times root 2 is simply 2. So x is root 2 and y is 2. Number 6, we got another 45, 45 right triangle, so both of those are the same, so x and y will be the same length. Now here, if I'm going from the small side to the hypotenuse, that has to be getting larger, right? So when I multiply the side times the square root of 2, okay, what is the square root of 2? Square root of 2 is 1.41, right? So when I'm going from the short side to the hypotenuse, the longer side, I'm basically multiplying by 1.41. Okay, now here I'm going from the longer side to the shorter side. So that number has to get smaller. So instead of multiplying by the square root of 2, I'm going to divide by the square root of 2. So 15 root 2 divided by root 2, those cancel. And then x is going to be equal to 15. Okay, if x is 15, then y is also 15. Because it's an isosceles triangle. Okay. Number 7, I don't have any angles, but if I know that side and that side are the same, and I know that's 90 degrees, if I have an isosceles triangle with a 90-degree angle, the only way that can happen is if it's our classic 45, 45, 90 right triangle. Okay, am I going from little to big, or am I going from big to little? Okay, I'm trying to find the hypotenuse, so I'm going from short to long. So that means I'm going to need to multiply by something. I got to multiply by the square root of 2. So y is the square root of 5, okay, times the square root of 2. If I multiply those together, I get y is the square root of 10. Okay. All right. Let's keep going here. Okay, so for number 8, now we're on to our 30, 60, 90 special right triangles. So let me just draw this image here real quick. I'll draw both of them here real quick. 45, 45. This is S, this is S, this is S root 2. For a 30, 60, 90, the short side is across from the short angle. So the short side is across from the 30. The hypotenuse is 2S. And the long side across from the 60 is S root 3. Now remember the little trick I taught you. If you can't remember which one is root 2 and root 3, root 2 is with the one that only has 2 angles. Only have 90 and 45. The root 3 is with the triangle that has 3 angles, 30, 60, 90, 3 different angles. Okay. All right, so I have my 30, 60, 90. Okay. Now the short side is across from the 30-degree angle. Okay, so this is S. Okay, this is the hypotenuse across from the 90, so this is my 2s, and this side across from the 60 is my s times the square root of 3. Okay. All right, so let's take a look at which side we're trying to find. It's always easiest with the 30, 60, 90 to find the short side first. Don't ever try to go from 2s to s root 3 or s root 3 to 2s. That's going to be confusing. Okay, so let's go get the side first. Now, I'm going from the hypotenuse, I'm going from 2s down to s. So I'm going from big to little. So that means I need to divide, right? So I need to divide this side by 2. Okay, so 2 root 3 divided by 2, the 2's cancel, and x is going to be equal to, I'm just left with the square root of 3. Okay, so s, or x, is the square root of 3. Now, to go from s to s root 3, I have to multiply by root 3. Well, my side is already root 3. So y is going to be the short side, root 3, and then I got to slap on another root 3. So I got to multiply times another root 3. Root 3 times root 3 is just itself. So y is going to be equal to 3. So we have x is the square root of 3, and y is simply 3. All right, number 9, this is also a 30, 60. I'm a big advocate of putting in the angles. This is a 60, that's a 30, if it's a right triangle. Okay, so let's label our sides. 30 is across from the short side, that's my s. The hypotenuse is my 2s, and the long side is the s times the square root of 3. Okay, so what information do we have? We have the short side. Oh, that's nice. Okay, so when they give us the short side, it's quite easy. To go from short to 2s, I just double it. Okay, so x is going to be equal to 12 times 2, so x is 24. And then to go from s to s root 3, I just slap on a root 3. So y is 12 times the square root of 3. That's always nice when they give us the short side. The hardest one is this one, number 10, when they give us the long side. Okay, so this is the information we have is across from the 60. This is my s root 3. The x across from the 30, that's my s. And the y is the hypotenuse across from the right angle. This is my 2s. Okay, so I got to go from s root 3 to s. I'm going from the long side to the short side. So that means I have to divide. Okay, so x is going to be equal to the long leg, 9 root 3. I have to divide by root 3 because I'm going from big to small. So when I divide by root 3, those cancel. I'm just left with x equals 9. Okay, so if x is 9, to go from s to 2s, I just double it. Okay, so y is going to be 9 times 2, which is 18. Y is 18. Okay, let's keep going here. Number 11, city planning. We've got a STEM problem. Real life application problem. This is the good stuff, right? Because this is why we learn all this stuff. Where can we apply it and use it in the real world? All right, so we got Jefferson Park sits on one square city block, 300 feet on each side. Sidewalks across the park join opposite corners. To the nearest foot, how long is each diagonal sidewalk? Now, I'm the math teacher, guys. When I read this problem for the first time, I was a little confused when I looked at this. Okay, 22 doesn't need to be there. This is problem number 11. I was a little bit confused. So guess what I had to do? I read it again. Read it 2 or 3 times. Okay, Jefferson Park. So we got a park. Okay, the park sits on one square city block. It sits on a square. Okay. Park sits on a square. Okay. So here's our park. It says 300 feet on each side. 300 feet. Well, if it's a square, all the sides are the same, right? So this is 300 feet. This is 300 feet. 300 feet. Okay. And it says sidewalks across the park join opposite corners. Joining opposite corners. Okay, so the sidewalk does this. So the sidewalk cuts across the park. Okay. It says to the nearest foot, how long is each diagonal sidewalk? How long is this diagonal? All right, so that's our variable x. Okay, if we have a square, then that means all 4 angles are 90 degrees. And if this is 300 and this is 300, this is an isosceles right triangle, right? So the only way that can happen is if these 2 angles are 45 degrees. So here's our classic 45, 45, 90. All right, am I going from little to big, or am I going from big to little? Okay, we're trying to find the hypotenuse, the longest side, so I'm going from little to big. So I got to multiply by something. What do I multiply by? Root 2, right? This is s, and this is s root 2. So x is going to be equal to the s, 300 feet, times the square root of 2. Now this says round to the nearest foot. It doesn't say leave it in simplest radical form. Since this is a real-world application problem, then it makes sense for us to get an actual number. Okay, so I'm just going to type in 300 square root of 2, and that gives me approximately, I can see that, 424 to the nearest foot. So that's approximately 424 feet. Does that make sense? Yeah, 424 is more than 300. So that makes sense to me. Okay, so let's keep going here. Let's look at problem 12. It says find the missing variables. Okay, so I see some information on some sides, so I'm wondering if I can use Pythagorean theorem. Let's see, I don't have that side and I don't have this side. So that tells me, probably not going to be able to use Pythagorean theorem. I see a 60 and a 45, so that ought to be a big blinking red light, a blig, to tell you, hey, I need to use special triangles here. Okay, so let's break this down and do these one at a time. Okay, so if this is, that's 90. If that's 60, this is 30. If that's 45, that's 45. And the first piece of information I have is over here on the 30, 60, 90. Okay, so let's just ignore, let's just ignore the 45, 45, 90 right triangle. Let's just focus on the 30, 60, 90. 30 is my short angle, so that's across from the short leg. So this is my S. The hypotenuse is my 2S. And the side across, the long leg across from the 60 is my S root 3. Okay, so how do I go from 2S to S? I'm going from hypotenuse to short leg. I'm going from long to little, so I have to divide. So C is going to be 4 square root of 3. How do I go from 2S to S? I divide by 2. Divided by 2. So C is going to be equal to 2 square root of 3. Okay, that's 2 square root of 3. Okay. Now, how do I go from the short side to the long side? How do I go from S to S root 3? I'm slapping on a root 3, right? So A is going to be C which is 2 root 3, and then I got to multiply times another root 3. Root 3 times root 3 is just 3. So a is 2 times 3, which is 6. Okay, so a is 6. Okay, now if this is a 45, 45, 90 right triangle, then this is isosceles, right? That side and that side are the same length. So if a is 6, then d has to be 6. Okay, so that's also 6. Now, how do I go from leg to hypotenuse of a 45 to 45? This is an s, and this is my s root 2. Okay, so to go from s to s root 2, I just slap on a root 2. So b is going to be the leg, which is 6, and I just slap on a root 2. 6 root 2. All right. All right, that takes care of the first page. Let's move on to the second page here. Move on to problem number 13. Okay. It says find the value of x to the nearest degree. Okay. All right. So Pythagorean theorem. I got a side. I'm not trying to find a side. X is inside the triangle, and it's got the little degree symbol, right? So I'm finding an angle. If I'm finding an angle, I will never use Pythagorean theorem, because Pythagorean theorem only deals with sides, okay? So this tells me, maybe can I use special right triangles? No, because I don't know what the other two angles are, so throw that out the window. Okay, so maybe I use trigonometry. Okay, so trigonometry is when I'm finding a side and an angle given 2 pieces of information. To use trigonometry, I need 3 pieces of information. I need 2 angles and a side, or 2 sides and an angle. Okay, here are my 3 pieces of information. I have an angle, that's 1. I have a side, that's 2. Another side, that's 3. That's 3 things. And I'm solving for one of those. I need two out of the 3. So this tells me I got to use trigonometry, and the way I taught you guys was to, step number 1, circle the angle. So your brain focuses in on that angle, because everything, all the other sides and labeling is reference to this angle. Step 2 is to label. What is the 5? The 5 is across. The 5 is not touching this angle. So this is my opposite side. This side would be my adjacent, but I don't need to label that because there's nothing there. And then 14 is my hypotenuse. Okay, that's my hypotenuse. I got dyslexia here. HPY. Let's try that one more time. Hypotenuse. Okay. So now I got to figure out which sine function has opposite and hypotenuse in it. Okay, this is my sine, right? So, okay. So opposite and hypotenuse is sine, S for sine. Okay, but I'm finding an angle here. Okay, so I'm not going to use regular sine, I'm going to use the inverse. So I'm going to use the inverse sine of opposite over hypotenuse, 5 over 14. Okay, so on my calculator, I'm using the inverse to find an angle. All the law of sines, cosines, trigonometry are always using inverse to find an angle. So I'm going to press second, and then I'm going to press sine. So there's my inverse sine with a little -1. And then I'm going to do opposite over hypotenuse. Press enter, and I get 20.9. It tells us to round to the nearest degree. So I will round that up to 21 degrees. Okay. Make sure my camera is focused. There we go. Okay, number 2, same thing. I'm finding an angle here. Step 1 is to circle the angle. Step 2 is to label. Okay, 8 is on the other side. That's my opposite. 5 is touching. This side of 5 is literally part of the angle x, okay? So that's going to be my adjacent. And then the hypotenuse across from the 90, we don't have any information, so we just leave that alone. Okay, so which trig function has opposite and adjacent? That's going to be my TOA, right? Opposite, adjacent, TOA, so I need tangent. Okay, but I'm using inverse because I'm finding an angle. So it's inverse tangent of opposite over adjacent. Okay, so my calculator, type that in. Second, inverse tangent of 8 divided by 5. and I get 57.99. We're going to round that up to 58 degrees. Okay. Number 3, step 1, circle the angle. Step 2, label. The 5.8 is my hypotenuse. The 3 is literally part of angle X. It helps form angle X, so that's going to be my adjacent. Which one has adjacent hypotenuse? That's going to be my cos, so toa, adjacent over hypotenuse. So that tells me I need sine, or excuse me, cosine is adjacent over hypotenuse. But I'm finding the angle, so I need inverse cosine of adjacent over hypotenuse. Doesn't matter, those are decimals. Okay, so let's go. Second, inverse cosine of 3 divided by 5.8. And I get 58.8, which rounds up to 59 degrees. Okay, so that takes care of those 3. And then here, I found this problem. I thought this was a good, interesting problem. Let's cut off here. Angle 28. Yeah. Okay, so I like this problem here. It says a ranger's tower is located 44 meters from a tall tree. From the top of the tower, the angle of elevation to the top of the tree is 28, and the angle of depression to the base of the tree is 36. How tall is the tree? Okay, so I'm trying to find this whole length here. Okay, well, from here to here, we're going to call that y, and from here to here, we're going to call that x. So if I knew what x was and if I knew what y was, I would add those together to find the height of the tree. So basically, we're going to have to solve 2 trigonometry problems all in the same problem. Okay, so for y, I'm going to circle my angle, and I'm going to label. The tree and the tower are 44 meters apart, so this length is also 44 meters. So I need to label. The y is my opposite. The 44 is my adjacent. So I need tangent, toa. Tangent is opposite over adjacent. Okay. Now here, I'm not trying to find an angle. I'm trying to find a side length. So here I use my regular trigonometry. So I set it up. So I set up the tangent of my angle, tangent of 28 degrees. Remember, that's some ratio, 0.6, 0.8, whatever. Your calculator already knows what that is. The tangent of 28 equals opposite y over adjacent 44. Now where is the variable? The variable is in the top. So what do I do with these 2 things? I'll multiply them. Or multiply both sides by 44. Okay, so y equals 44 times the tangent of 28. Okay, so type that into my calculator. 44 tangent of 28, I get 23. Now here, don't round early, guys. So anytime you're doing a problem in math where you solve something and then you got to go over to somewhere else to solve something else, you don't want to round early because then your final answer won't be as precise and accurate. So here, I'm going to leave it. I'm going to leave it as 3 decimal places, 23.395. Okay, and I'll come back to that. So now we're back over here trying to solve for x. Okay, so now we're going to be using this triangle. Okay, step 1, circle the angle. Step 2, label. 44 is adjacent. X is the opposite again, so we need a tangent one more time. So I'm going to set it up. I'm going to say tangent of my angle, tangent of 36 degrees is equal to opposite x over adjacent 44, and it's the same thing. The variable's on the top, so I'm going to multiply those together. So x is going to be 44, but this time it's times the tangent of 36 degrees. That comes out to be 44 tangent of 36. That comes out to be 31.968. 31.968. Okay, so now to find the height of the tree, I'll call this z. Okay, the height, or z, is equal to, you just add these 2 guys together. 23.395 plus 31.968. You add those together, and we get 53. We get 53.363, Now in this case, now that I'm at the end, I'll go ahead and round this to the nearest tenth. It doesn't tell us what to round to. So I'll round this to the nearest tenth and say that is 55.4 what? Meters. This is a real life application problem, so we need those units. 55.4 meters. Okay, let's keep going here. All right, down to the next problem. I love this problem. I love that I handpicked this one, okay? So this is a really cool problem. So we have a tower here. We have an electrical tower here. And it's asking us what is the length of the top section of the tower. It's kind of hard to see here, but we got some structures up here. Okay, and they're asking us what is the length of the top section, just that piece. Okay, well, that's not part of a right triangle. Okay, that's part of this acute triangle here. So I've got to use, I got two different angles here. I got the big angle is 40 degrees. I got the little angle, which is 25 degrees. And then I have this ground distance from the person or whatever to the bottom of the base of the tower. We know that's 87 feet. Okay, so in order for me to find this piece, I'm thinking, okay, well, if I knew the whole piece and I knew the bottom part of the tower, then I could do the whole tower minus the bottom part, and that would give me the top part, right? So that tells me I need to find this bottom part. Okay, so my brain is thinking, okay, I need to focus first. I need to focus on this triangle down here in purple that I just highlighted. Okay, so to do that, I'm going to put a variable here. We'll call this y. Okay, so now I've got this 25-degree angle. So step 1 is to circle the angle. Step 2 is to label. Y is my opposite. 87 is my adjacent. Okay, I'm not finding an angle, I'm finding a side, so this is my regular trigonometry. So I'm going to say we need tangent, opposite, and adjacent. So I'm going to say tangent of this 25-degree angle is equal to opposite over adjacent, y over 87. The variable is in the top again, so I'm going to multiply these two things together. So y is 87 times the tangent of 25 degrees, and that comes out to be 40. Again, I'm going to round this to a few decimal places. I don't want to round too early. Okay, so this piece is 40.569. Okay, all right, I got the bottom piece, but now I need the whole piece. Okay, so I'm going to do this in green. So I'm going to come out here and say this whole piece, the whole height of the tower, I'm going to call that Z. And now I'm looking at the green triangle here. I'm looking at the big triangle. I'm looking at this guy, okay, the green triangle. All right, so if I look at the green triangle, I got this angle of the green triangle, which is 40 degrees. So again, it's the same thing. Step 1 is to circle the angle. Step 2 is to label. Z is my opposite, and then the 87, once again, is my adjacent. Okay, so I'm going to do the same thing. I'm going to say tangent of the larger angle, tangent of 40 degrees is equal to the opposite side, which is Z, over the adjacent side, which is 87. Same thing, variables in the top. So I'm going to multiply those. So Z is 87 times the tangent of the larger angle, 40 degrees. That comes out to be 73.001. Okay, and now I'm ready to go find X. X, the top piece, is the whole piece minus the bottom piece. So X is going to be equal to the whole piece minus the bottom piece, Z minus Y. So what is Z? Z we just found was 73.001, and Y we said was the 40.569. If you subtract those, you come out, again, it doesn't tell us how to round, so I'll round to the nearest tenth here. So we'll call it 32.4 feet. Does that sound reasonable to you? Does it sound reasonable that a tower would be 73 feet tall? 7 basketball goals, 10 foot. 7 basketball goals tall? Yeah, I buy that. The top half is 30 feet, 10 yards. Yeah. Sounds reasonable to me. All right, 18, the angle of elevation from the shorter tower to the top of the taller tower is 30 degrees. Angle of elevation, so we're looking up. Okay, so we got this 30-degree angle. Oh, sorry, I can't see that. So you got this 30-degree angle for a person standing on the shorter tower. They're looking up at an angle of elevation of 30 degrees. The towers are 40 meters apart from the ground, from the base to the base. They're 40 meters apart. What is the height of the taller tower? Okay, well, the shorter tower is 30. Okay, so from here to here is 30. Okay, so I need to just find this top section and then add them together, similar to what we did on the previous problem. Okay, so that tells me, okay, I got to use this triangle here. Looking at this purple triangle. Okay, I have an angle. I need to solve for this side of the triangle, so I'll put a variable there. I'll call it x. Oh no, I was going to call it y. X. There we go. Okay, so step 1 is to circle my angle. Step 2 is to label. X is my opposite. 40 is my adjacent. Notice how in a lot of these real-world problems we're using a lot of tangents. Okay, so I need tangent again. Am I solving for an angle? Nope. I'm solving for a side, so that's regular. Tangent of my angle, tangent of 30 degrees, is equal to opposite over adjacent. So once again, the variable's in the top, so I'll multiply those two. So that's going to be 40 times the tangent of 30. Okay, so you plug that into your calculator. That comes out to be 23.09. So this piece is 23.09. And now I'm ready to just add these two numbers together to get the height of the taller tower. So we can say the height, or we can call this y if you want to. Height of the tower, y is equal to 23.09 plus the height of the shorter tower, which is 30. And that comes out to be, again, it doesn't tell us how to round, so just round to the nearest tenth. 53.1 what? Meters, which is a little more than a yard. 50 meters. If that were, that's going to be a little bit more than a yard. A meter is a little bit more than a yard, but let's just say it was in yards. 50 yards, half of a football field. You buy that a building is half a football field tall? Sure, I'll buy that. Sounds reasonable. Okay, so let's keep going. Number 19 here, solve for x. Okay, we got a couple of angles. We've got a variable on a side. We've got another side. So the first thing that I notice is that I don't have a box. Okay, I don't have a right angle. It looks like it's a right angle, but remember what we do with our eyeballs. Okay, if we don't know that it's a right triangle, we cannot assume it's a right triangle unless we have some other information. So everything that we've done up until this point, Pythagorean theorem, special right triangles, all this trigonometry stuff is all based on the fact that all of these angles, okay, we are making the assumption, all these angles are right angles. Because trigonometry, special right triangles, Pythagorean theorem only work with right triangles. Notice in 19, we don't necessarily have a right triangle. Okay, the word problems, you know, it's just kind of understood. We assume those are forming 90-degree angles, but I can't make that assumption here. Okay, so that tells me I'm going to have to use the law of sines or cosines. All right, so what do I have here? I have an angle, and a side. I have angle, side. I have AAS. Okay, so that tells me I'm going to use the law of sines. The law of sines is used for three things: AAS, ASA, and the bad word, SSA, spelled backwards. Okay, but I have AAS, so I can use it. And the law of sines tells us that the sine of one angle across divided by its side across from it is equal to the sine of another angle divided by the side opposite it. Okay. All right, so I can set up my formula, set up my proportion to say sine of this angle divided by the side across from it, sine of 46.5 divided by x is equal to the sine of this angle divided by the side across from it. Sine of 39.4 degrees divided by its opposite side, which is 7. Now I can cross multiply, do the butterfly. X times the sine of 39.4 is equal to, cross multiply here, 7 times the sine of 46.5. Okay, so over here I need to get x by itself, so I'm going to divide both sides by the sine of 39.4. Those will cancel. And I'm left with x is equal to 7 sine of 46.5 divided by sine of 39.4. Now, when I taught this lesson in class, I told you guys something like this, you would need to use parentheses here just so your calculator doesn't get confused. To me, the easiest thing to do is just type in the numerator first. Just type in 7 times the sine of 46.5. I get that. And then I'm going to press divided by that, divided by the sine of 39.4. And we get that, 7.999, which we'll round that up to 8. So x is 8. I think my pen is running out of ink. Okay. All right, law of sines there. All right, just flip on over to the back, coming down the home stretch here. Okay, it says find the measure of angle C. Find the measure of angle C here. Okay, so I actually went back, guys, at my initial draft of this test review. I didn't say what to round to, but I went back and changed all that. So this one we're going to round to the nearest tenth. This one I went back and said round to the nearest tenth of a degree. This one, the next one I said round to the nearest number. And this one I said round to the nearest degree. And the last one I said round to the nearest degree. So the last one says solve for x round to the nearest degree. Okay. All right, sorry about that. So if y'all want to add this to your paper real quick, round to the nearest tenth, round to the nearest tenth, round to the nearest whole number, and then round to the nearest degree, and then round to the nearest, solve for x, round to the nearest degree. And there's the x should be right there. So we're basically solving for angle C. Okay, sorry about that. All right, let's keep going. So find the measure of angle C. Okay, so when I'm finding an angle, I can't use trigonometry, Pythagorean theorem, special rights, because we don't know that this is a right triangle. So that tells me I need to use the law of sines or cosines. Now what do I have? I have an angle and a side and a side. Okay, so I have side, side, angle. That's the bad word, right? SSA. Okay, but this does work. I can use the law of sines for this. Law of sines. SSA. Okay, so I can set up my proportion. I can say the sine of 30 degrees over its opposite side, sine of 30 over 5, is equal to the sine of the angle in question. I'll put an x right there. So I can say equals the sine of x, or the sine of C, doesn't really matter, over its opposite side, which is 8. Cross multiply, I get 5. Sine of x is equal to 8 times the sine of 30. Now I need to get x by itself, so I got to get rid of this 5. So I got to divide. That's multiplication. That's not addition. Multiplication. So divide both sides by 5. So now I have sine of x is equal to 8 sine of 30 over 5. Now there's one of two ways that you could do this. One way, I'm finding an angle, so I got to use the inverse. Okay, so one way to do this is you could type all of this into your calculator if you wanted to, but you really have two sets of parentheses. So probably what I would do, you can do it that way. You can do two sets of parentheses, but probably to me the easiest thing to do is let's just type this into our calculator and get a number. 8 sine of 30 is 4, because remember sine of 30 is 1/2, divided by 5 is 0.8. Okay, so the sine of our angle is in a ratio of 80%, 0.8. So this is just 0.8. So then probably what I would do is I would take the inverse sine of that answer. So second inverse sine of second answer. That gives us 53.1 degrees. That says round to the nearest tenth. So we get angle C is, or X is equal to 53.1 degrees. Okay, so let's keep going here. Number 21, solve for X. Round to the nearest tenth of a degree. I'm finding an angle here, but what's the information I have? I have side, side, side. S, S, S. Okay, so once again, if I have SSS, what is this? Is this law of sines or law of cosines? This is actually law of cosines. Remember, the law of cosines works for SSS or SAS. Okay, all right, so law of cosines. This is one that's a little bit trickier, and that formula tells us that the side across from the angle in question, we're going to square that. A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Okay, so it's always based around these two guys, the angle in question and the side across from it. Okay, so here's my angle, here's the side across from it. So this is my angle A, and that is my A. Okay, I don't want you guys to get wrapped up in the whole BCA thing. It doesn't really matter how the stuff's labeled. You just need to remember that with the law of cosines, it's the side across from the angle is the one that comes first. Okay, so this is my A. So I've got 16 squared equals B squared and C squared. 2 plus 3 is the same thing as 3 plus 2, so it doesn't matter which one these are. We're just going to pick one. It doesn't matter. Well, I'll let the 8 be the B. 8 squared plus 22 squared minus 2 times B times C. 8 times 22 times the cosine of my angle, which is X, cosine of X. Okay, let's go ahead and simplify all this. So we plug this into our calculator. This is going to come out to be 256 equals 64 plus 484 minus 2 times 8 times 22 is 352 times the cosine of X. Okay, we need to get cosine of X by itself, so let's simplify this. If I add those together, that becomes 548 minus the 352 cosine of X. Let's move the 548. I always have to think about this as a two-step algebraic equation. If I had 10 equals 6 plus X, or plus, say, 3X, what would you do first? I got to move this 6 to the other side, right, before I divide by 3. It's the same thing here. I got to move this guy to the other side before I divide by the negative 352. So I'm going to subtract 548 from both sides. Those will cancel. So 256 minus 548 gives me negative 292. That's going to be equal to the negative 352 cosine of X. Now to get cosine of X by itself, I've got to divide both sides by negative 352. Those cancel. And I get cosine of X is equal to negative 292 over negative 352. That comes out to be 0.8295. And so I'm trying to find an angle, so I got to do the inverse of that number. So inverse cosine of that number. Now here, you could just type this into your calculator. Okay, you could just type in inverse cosine of negative 292 divided by negative 352, and we get that. Or I can just type in what I got here, inverse cosine of 0.8295, and of course we get basically the same thing, just because I round. Again, you can see why if you round early, we don't get the exact number, but it's close enough. We're just rounding to the nearest tenth of a degree here. So x is equal to 33.95. So we're going to round that to oh, you know what? And this is exactly what I was talking about. This is exactly what I was talking about. So this is why you really shouldn't round early, and you should try to get an exact answer. Because if you type in it this way, you do the inverse cosine of these two numbers, you get that. If I say round that to the nearest tenth, that's 33.9. If you round early, even though I kept this out to 4 decimal places, that's still a little bit of a difference. So when I take the inverse cosine of that number, that's actually going to change it, because the way I have it, this would round, the 5 rounds that up to a 0. This would actually be 34.0. But since we want to be precise and completely accurate, I'm going to leave it as the 33.9 number. But just know you can be off by a tenth, even if you carried it out 4 or 5 decimal places. Okay, so rounding is very important. I know you guys don't like, when you're off by a tenth or whatever, but I'm here to tell you guys, I was an engineer for 10 years, and there's a big difference between 33.7 and 33.8. I mean, that could be the difference of tens of thousands of dollars when you're talking about manufacturing equipment and sending out product on an assembly line. It's a big deal. Okay, let's keep going to the next one. 22, solve for b, round to the nearest number. Okay, what information do I have? I have a side, angle, and a side. I have S, A, S. And I have the side across from it I'm trying to find. SAS, that is law of cosines. Okay, SAS. So law of cosines only applies to 2 things, SSS and SAS. Law of sines applies to 3 things, AAS, ASA, and the bad word. Okay. All right, so let's go ahead and set up our formula. So remember, again, I don't want you guys to think about A's, B's, and C's. I really just want you to understand that it's the side across from the angle. That's the one that comes first in the formula. So it's going to be that guy squared. So b squared is equal to the other 2 sides squared. So equals 15 squared plus the other side squared minus 2 times multiplying both of those guys together times the cosine of my angle. Now this time I have the angle. So cosine of 124 degrees. Now, when you have the angle, okay, you literally can type all that into your calculator exactly the way you see it, okay, because I'm not having to use the inverse. So your calculator will do the order of operations correctly. All I'm doing is adding and subtracting here. I'm adding and subtracting. Everything else is multiplication, okay? So I'm just going to type this in exactly the way I see it. So I got 15 squared plus 20 squared minus 2 times 15 times 20 times cosine of 124, and I get that number. Okay, but that's what b squared is equal to. B squared equals this 960.52 number. Okay, I want b. So I take the square root of that, second square root of second answer, and I get, now this tells us to round to the nearest number, so we can round this up to 31. Now, does that answer make sense? 31 is bigger than 15 and 20. Why does that make sense? This guy is an obtuse angle. You can only have one obtuse angle in a triangle, right? If you had two angles that were both 100 degrees, 100 plus 100 is already 200. You're already over 180 degrees. That can't happen. So anytime you see an obtuse angle, remember our inequalities in one triangle. This is the winner, and this is the winner, right? So B has to be bigger than 15 and 20. So yeah, I buy that. That makes sense to me. All right, let's keep going. Last 2 here. We got a couple of combination problems. I love these types of problems. Combo. My brother is like one of the best Street Fighter arcade players you ever meet in your life. He loved combinations. Mortal Kombat, for you gamers out there. Okay, find the measure of angle D, round to the nearest degree. Okay, angle D. All I have is a side and a side. If I'm only looking at the top triangle, all I have is a side and a side. That's not going to cut it. So that's going to tell me I need to use the stuff down here. Here I have side, angle, side. Side, angle, side. I'm still in the land of law of cosines and sines because we don't have a right angle here. So all that other right angle stuff in this unit doesn't apply. Okay, so I can use the law of cosines here. I can use the law of cosines to find the side across from this angle. I can use that to find AB, okay? Now, I'm going to throw a variable in here. I'll just throw in an x, okay? So law of cosine says the side across from the angle, that's going to be the squared guy. So x squared is equal to these two sides squared. So 60 squared plus the other side squared minus 2 times, and multiply both of those together. 2760 times the cosine of my angle, which I have, cosine of 121 degrees. Okay, now once again, when I'm finding the side, I can just type all that straight into my calculator. I'm not going to do that again. If you type all this into your calculator, you're going to get x squared is equal to this huge number, 5,997.7. We're going to take the square root of that. Next is going to be 77.44. Okay, so this length is 77.44. Okay, now I have side, angle, side, and the side across from it. So once again, I have side, angle, side. Okay, so side, angle, side, law of cosines again. So we get to have some more fun twice. Okay, so my side across from the angle, that guy is squared first. So I have 77.44 squared equals, square both of those guys, 55 squared plus the 35 squared minus 2 times the product of both of those, 55 times 35 times, now this time I'm finding an angle, times the cosine of the question mark. Okay, so I'll say cosine of D because we're asked to find measure angle D. You could put a variable there. I'll just leave it as D this time. Now here I can't type all that into my calculator because all of this is being multiplied to this. I got to get this guy by itself. So we got to do some simplification here. So 77.44 squared gives us back to that big number, the 5,997.7. If I square 55 and 35 and add those together, that comes out to be 4250. And then 2 times 55 times 35 gives me minus 380.50 times the cosine of D. I got to move the 3850 to the other side, or excuse me, move the 4250 to the other side. Okay, those cancel. That number minus that number comes out to be 1,747.7 equals the negative 3850 times the cosine of D. I got to divide both sides by the negative 3850. Okay, now here, last time, you saw that when we got a number and did the inverse cosine of that, we were a little off. So this time, I'm going to do the inverse cosine of this exact thing. Okay, the 1747.7 number over the negative 3850. If you do inverse cosine of that number over the negative 3850, you get the measure of angle D comes out to be, and we're rounding this to the nearest degree. So this actually rounds to 117 degrees. All right, last problem, you made it. You made it. Solve for x, round to the nearest degree. Okay, so once again, this is a combo problem. All right, I look down at this triangle, I have side, angle, side. Okay, so I can use law of cosines here, SAS. That will help give me dB. Okay, so we already have an x here, so I'll use y for the length of dB. Okay, so the side across from my angle squared, so I'll start with that guy. Y squared is equal to, square both of those, 5 squared plus 7 squared minus 2 times the product of both of those. Oops. 5 times 7 times the cosine of my angle, which I have, cosine of 71 degrees. Now when I'm finding a side, I can type all that straight into my calculator exactly the way I see it. If you do that, you're going to get y squared equals 51.2. Then we want the square root of that, so y is equal to 7.16. So this guy is 7.16. Okay. So now over here on the top triangle, what do I have? I have side, angle, angle, side. Okay. So I have side, side, angle, SSA. So on this one, we're actually going to use the law of sines. We have SSA. Okay. So I can set up a proportion to say the sine of this angle over its opposite side. So the sine of x over its opposite side, which we just calculated, was 7.16, is equal to the sine of this angle over its opposite side. Sine of 43 over the 6. Okay, cross multiply. We get 6 sine of x is equal to 7.16 times the sine of 43 degrees. I got to get x by itself, so I need to get rid of this 6. So I'm going to divide both sides by 6. So now I'm going to do the inverse sine of 7.16 sine of 43 all over 6. Okay, so now if we want to do this in one step, I think the first time I did this, back up top, I went ahead and got a decimal and then took the inverse sine of that. If we want to be a little bit more accurate, I can do inverse sine, second inverse sine of, now you already see we got one set of parentheses, okay? So I'm going to do 7.16 times the sine of another set of parentheses, okay, sine of 43, close that parentheses, okay, divided by 6, and then I got to close that parentheses again. Okay, so and this is why I say I don't like to do things like this in multi-steps, because if you don't put the parentheses there, okay, I get that. Inverse sine of 7.16 times the sine of 43 divided by 6. Okay, actually in this case it doesn't matter, but there will be times where it does matter when you have two sets of parentheses here. Sometimes you can get a different answer, but in this case it doesn't matter whether we close the parentheses. With these trigonometry functions, if I do sine of 47, your calculator is fine with you not closing the parentheses. Sine of 47, close it, you get the same thing. But just trust me, guys, when you guys get further along in math, advanced algebra, and that kind of stuff, if you don't have the correct number of sets of parentheses, you can get wrong answers. So I tend to shy away from that when I do stuff with my calculator. But in this case, we do get that x is equal to the 54.47, which rounds down to 54 degrees. Okay, a lot of stuff, guys. Hope you guys enjoyed that video. Study hard, and we will see you on the next one.